The sum and difference identities actually lead us to what we call the cofunction identities. They're pretty powerful identities, and actually they make a whole lot of sense in multiple ways. First of all, I'm just going to point out why they're called cofunction identities. Okay, our trigonometric functions, there's really three names we have: sine, tangent, and secant, and then co in front of those: cosine, cotangent, and cosecant. Okay, and these are the relationships that exist among them. The sine of 90 degrees minus an angle theta is equal to the cosine of that angle. Now, you can actually prove this identity using the difference identity for the sine function, and that's valid for all angles. One way to just understand intuitively why this is true is to look at a triangle. And of course, the triangle really only makes sense for thinking of acute angles. But if this is our angle theta right here, because the angles of a triangle have to add up to 180 degrees, and this one is 90, then these two angles have to add up to 90 degrees, which makes this angle right here 90 minus theta. 90 degrees minus theta. Okay, then if we look at these three sides, I'm just going to give these three sides names. I'm going to call them A, B, and C. And then I'm just going to write one of these. I'm just going to look at the sine. Okay, the sine of 90 degrees minus theta, that's this thing right here. Okay, the sine of an angle is the opposite, which is A, over the hypotenuse, which is C. Well, notice that you can also view that as the adjacent of theta, okay, over the hypotenuse, which of course is the definition of the cosine. Okay, and so that is why these all six of these identities work, is because really, if you just look at a triangle, we're looking at these two different angles, and with respect to each of those angles, the opposite and the adjacent end up flipping, and that creates all of these cofunction identities for us.